All right, so you guys know that I am away today. We're going to do a bit of a video lesson. Hopefully you remembered your headphones and didn't have to leave class to go get them. We're going to do a quick review. I'm going to give you some questions to work on that, and then we're going to look at one other thing today. That's the plan. So right now we have taken trig, and we've learned our new x, y, and r definitions for sine, cos, and tan. We're just going to take a look at what we have done to date with them. Basically, two things. We have either stated the exact trig values or we have calculated the angle and standard position. And we do those things given different information. So we're going to take a look at the information we've been given and what we do with it. So first example, if I give you a point, then you know exactly where that angle is, and you can calculate the trig values, sine, cos, and tan, and you can calculate the angle and standard position. So if I have the point -5, -3, I know that my angle is over here in quadrant 3, and there's my angle theta in standard position. To state the exact trig values, I need to know my x, my y, and my r, so I can fill those in to the formulas for sine, cos, and tan. Y over r, x over r, and y over x. So I know my x and my y, and I know that my r, whoops, I said r and I wrote it, my x and my y, and my r is my hypotenuse, so I simply have to do Pythagorean theorem to figure out what r is. So -5 squared, -3 squared, so r will be the square root of 25 and 9, 34. So sine is y over r, -3 over root 34. Cos is x over r, -5 over root 34. And tan is y over x, so -3 over -5. And we know that two negatives simplify to a positive. So that, ladies and gentlemen, is stating the exact trig values. Second, calculating the angle. We have talked about how to use any of sine, cos, or tan. It doesn't matter which one we use as long as we ignore the negative, because by ignoring the negative, that allows us to calculate the RAA. So if I do sine inverse of +3 over root 34 and get my RAA, if I had a calculator ready to go, that would be good. There we go. And I would get about 31 degrees for my RAA. And we remember that the RAA is the angle between the terminal arm and the closest x-axis. So that my actual angle in standard position for this question is 180 plus 31, which puts us at 211 degrees. So that's determining an angle. So the two things, stating the exact trig values, determining the angle. Then you can be given different information. You might be given a point. You might be given a trig value. So this question tells us that cos is -3 over root 27 and that the angle is in quadrant 2. So that makes sense because cos is x over r, x is negative, and x would be negative in quadrant 2. So there's my angle theta. Determine the exact values for sine and tan and determine the value of angle theta in standard position. All right, so if I'm going to do the exact values for sine and tan, I need to know my y value because I have to know all three x, y, and r in order to fill in sine and tan. So usually I'm figuring out my radius, which would be x squared plus y squared. This time I know my r value, so instead of adding, I'll end up subtracting to find out y. So I have to do square root of 27 squared minus -3 squared. So we will have 27 minus 9, which should be 18. And then I'm going to do the square root of 18, which leaves me with my y value. So technically, my sine would be y over r. And in quadrant 2, this is very important, my y values are positive. So my y would still be a positive number, and my r value is still root 27. And tan is y over x. So I discovered y was root 18, and y is positive in quadrant 2, and my x is negative 3. So it's negative root 18 over 3, and we already know cos. So some things to watch for on a question like this is make sure you have the proper sign. So positive or negative with x and y based on the quadrant your angle is in. Another thing, another thing that's going to happen as we work through this is we're going to do some work with radical numbers. That is numbers with square roots. So there's a little bit of work we need to do to work with radical numbers to make our answers perfect. But for now, we're going to focus on the trig. So basically right here, I've done the same thing as I did above. I stated my exact values. It gets a little more complicated because I have to make sure that I have the right sign for x and y for the right quadrant. So I have to watch that, but it's the same exact thing, stating the values. And then once I know my values, every single time, calculating an angle is the same thing. I ignore the negative and figure out what my RAA is. So in this case, I'm going to do cos inverse of 3 over root 27, which means my angle is 55 degrees. And if my angle's in quadrant 2, then theta is actually 180 minus 55 degrees, which is 125 degrees. So two things, stating the exact value on the left, calculating the angle standard position on the right. Just given some different information, but I'm still doing the same thing. My last example is what we were getting into on, oh my goodness, what day was that? Thursday? No, Monday. Tuesday. So mixed up. Tuesday, when we started looking at a question like this, when we're given the trig value, which is like what happened up here, I was given the trig value. But the difference is my example here that we've already done told me my angle was in quadrant 2. Sometimes I'm given the trig value and I'm not told what quadrant it's in. And that's where we started talking about, hey, we could have two different answers, and we talked about this cast law thing. So it's really important to figure out where your angle is. That's the first step. So I'm going to look at where my angle is. If tan is positive, 2 over 3 is a positive answer. Well, tan is always positive in the first quadrant. Or if I had two negatives, tan would be positive in the third quadrant. So I could have one angle that's in the first quadrant, or I could have a second angle that's in the third quadrant. And tan would give me a positive ratio in both of those quadrants. Once I decide where my angles will be, do the same old thing, get my RAA. And everything's positive here. So I'm going to tan inverse of 2 over 3. I set my calculator down again. Which gives me 34 degrees. And my first angle is exactly the same because it's in the first quadrant. And my second angle, I would have to add 180 to my 34. I can fix that up. Because it's in the third quadrant, which means my angle is 214 degrees. So this time I did not state the exact trig values. All I did was solve the angle when I was given the trig value. So if I look at my next one, cos is negative 2 over 5. So I have a negative cos. That means when I look at my angles, that my x value is negative. Or if I use my cast law, they're all positive in the first quadrant. Cos is positive in the fourth quadrant, which means I have one angle in the second because x is negative in the second, and I have a second angle in the third because x is still negative in the third quadrant. Once I decide where my angles are, same deal. I will get my RAA and calculate my angles in standard position. So the RAA is cos inverse. Ignore the negative. Come on, calculator. 2 divided by 5. Cos, and I've got 66 degrees. So one of my angles will be 180 minus 66, which gives me 114. And the other angle will be 180 plus 66, which gives me 246. So again, I didn't state the trig values this time. I just calculated the angles when I was given the trig value. All right, last one. Same deal, sine. I mentioned this yesterday in class. Just times sine is a decimal instead of a fraction. Same process happens. It just means it's not in fraction form. It's been rounded somewhere along the way. So I'm looking for where sine is positive. I know sine is y over r. R is always positive, which means if I have y over r and I get a positive answer, both of them have to be positive. So y has to be a positive number, which happens in quadrant 1. Because of our cast law, all the trig functions are positive in quadrant 1. And y is also positive in quadrant 2. So the cast law tells us where they're positive. We talked about this on Tuesday. So all of them are positive in quadrant 1, and sine is positive in quadrant 2. So if I have a positive sine value, I know where to find it. It doesn't matter whether you use the cast law or whether you use what you know about x's and y's, the points being positive and negative, as long as you can locate where your angles are. So after I decide where my angles are, it's the same process every time. Find my RAA by doing the inverse trig of the positive value. And I get my calculator. 0.4125 gives me 24 degrees. Since one of the angles is in the first quadrant, one of them is 24. And since the other one is in the second quadrant, it'll be 180 minus 24, which is 156 degrees. All right, your job now is going to be to practice some of that, and then we'll look at our second note in a minute.